Hey friends, this is Monica Bansal. Today we're going to talk about type of numbers. So let us see. The very first category is of natural numbers. So what do we mean by natural numbers? We call them counting numbers also, cardinal numbers also. As the name suggests, we can count using natural numbers. So definitely whenever you count, you say 1, 2, 3, so on up to. So these numbers, the list of all these numbers, 1, 2, 3, 4, 5, so on up to. There is no end to these numbers. They are known to be natural numbers. And once again, we call them counting numbers. We call them cardinal numbers. They start from 1. They are never ending. We don't know the highest natural number. Now coming to the next category, that is whole numbers. So if we take 0 to the list of natural numbers, so if we add 0 to this list, you can see this is what? This is natural cardinal counting numbers. Okay. So this 0 if we take, so this whole list is known as whole numbers. So guys, can we say that 0 is the smallest whole number, right? Also, we can say that all natural numbers are whole numbers. But the vice versa is not true, right? All natural numbers, because all natural numbers means 1, 2, 3, so on up to. Whole numbers mean 0, 1, 2, 3, so on up to. So definitely all these numbers are lying in this category as well. That's why all natural numbers are whole numbers, but vice versa is not always true. Why? Because of this 0, right? 0 is a whole number. 0 is not a natural number. That's why. Now coming to the next category, which is even numbers. What do we mean by even numbers? Whenever we divide a number by 2, whatever be the quotient, if remainder we are getting a 0 always. 0, it means what? It means this number should come in table of 2. So if we take say 44, 44 if I divide it by 2, I'll get 22 as the quotient and 0 as the remainder. So all those numbers which when divided by 2, leaving a remainder of 0 are known to be even numbers. For example, if we take 2, if we divide it by 2, definitely we are going to get 0 as the remainder. So basically, what do we mean by even numbers? 2 ka table, 2, 4, 6, 8, 10, so on up to. So can you say even numbers discussion was very easy, but here there is one problem. What about this 0? Now let us see. If we divide this 0 by 2, now you write always quotient here. So I'm putting 0 here. 2 times 0 is 0 always. So what is the remainder we are getting? 0 again. So I can say that 0 is an even number, right? You should always remember these kind of things. We are comfortable to know that 2, 4, 6, 8, so on up to. This is nothing but 2 ka table. So 2, 4, 6, 8, 10, so on up to. All of them are even number. You must be comfortable in that. But the problematic part is here. What about 0? 0 is an even number. Now coming to the next category, which is odd numbers. Those numbers which are not even, which are not even. So what we are left with? I told you 0, 2, 4, 6, 8, so on up to. This is the list of even numbers. So which are not even? Numbers which are not even. Remaining numbers are 1, 3, 5, 7, so on up to. So we call them odd numbers which are not even. They are known to be odd numbers, right? Or to be very precise, we can say when we divide a number For example, if we take 19, when we divide 19 by 2, what will we put here? 9. So 2 nines are 18. So what will be the remainder? 1 will be the remainder. So whenever a number is divided by 2 and we are getting a remainder of 1, this number is known to be odd number, right? So it will be 1, 3, 5, 7. What should be the next one? What should be the next to 7 odd number? We should add 2 to that, 9. Now what should it be? It will be 9 plus 2, 11. 11 plus 2 will be 13. So can you say that whenever we take two consecutive odd number, now this is a new word for you, two consecutive adjacent, they are neighbors to each other, two consecutive odd numbers, we always say, I can say that 71, this is an odd number, right? So 71 is an odd number. If I ask you, what should be the next number? You will say 73. Now 71 and 73, they are two consecutive odd numbers because they are coming next to each other. They are adjacent neighbors. That is a meaning of consecutive numbers. Now, coming to the next category, which is very important, prime numbers. Now, what do we mean by prime numbers, guys? Prime number is a natural number. First of all, it should be a natural number. So definitely we can talk about prime numbers in this category. That should be a counting number which has exactly two factors. I hope all of you understand this word, factors. So before starting prime numbers, let us talk about factors. So what do we mean by factors? Let us take 15. Now, what are the factors of 15? Any number which is dividing 15 and giving no remainder, or we can say giving a remainder of 0. For example, if I divide 15 by 3, I'll take 3 5s are 15. So 0 is the remainder, right? Now, if I divide 15 by 4, so it will be what? It will be 4 3s are 12. So what will be the remainder, guys? It will be 3. So here 15 is exactly divisible by 3. Why exactly divisible by 3? Because remainder is 0 here. But here, when 15 is divided by 4, we are getting a remainder of 3. That's why 15 is not exactly divisible by 4. So whenever a number is exactly divisible by any other number, then that any other number will be factor of the number, right? So in this case, if I talk about particularly 15, so what will be one of the factor of 15? Can you say 3? Here 4 is not a factor because we are getting a remainder of 3 here. Here 3 when divides 15, we are getting a remainder of 0. So 3 is a factor of 15, or we can say, guys, once again, speak with me, 3 is a factor of 15 because 3 is dividing 15 exactly without leaving any remainder or leaving a remainder of 0. Or we can also say that 15 is a multiple of 3. This is a new word now. 15 is a multiple of 3. 3 is a factor of 15 and 15 is a multiple of 3. So these are some terms that I'll use in this type of numbers topic. So let us come back to definition of prime numbers. Now you can understand. Prime numbers is a natural number. So we should stay in this category 1, 2, 3, which has exactly two factors, right? Let us assume some numbers. Let us take, say, 15 that we have discussed. So can you say 1 will always divide 15? 3 is also dividing 15, that we have seen. Also 5 is dividing 15. Also 15 is dividing 15. So how many factors of 15 are there? Can you say 4 factors? There are 4 factors. Let us take one more number. Let us take 24 now. Now this is a big number. Now you pause the video, you try to write all the factors of 24 by yourself. Now let us see. 1, then we have 2. 2 is dividing 24. 3 is dividing 24. 3 8s are 24. 4 is dividing 24. 5 is not dividing 24 because when 24 divided by 5, remainder will be 4. I think you can manage this kind of calculation. Now, if I go to 6, 6 4s are 24. 7 is not a factor of 24. Now you can understand the meaning of factor. 8 is a factor of 24. Then we have 12 is a factor of 24. 24 itself is factor of 24. Now see carefully, guys. When I was writing factors of 15, I wrote 1 and 15. And while writing 24, I wrote 1 and 24. So guys, can I say whatever be the number here, 1 will always be a factor because 1 divides everything, every number. And the number itself, can you say this? Whatever be the number here, 1 and the number itself that we have seen in the case of 15 and 24. So these two definitely are factors of the number. What? 1 and the number itself, right? Now coming to the definition of prime numbers. Prime numbers is a natural number which has exactly 2 factors. As we have seen that whatever be the number, 1 and the number itself, they are already are factors of the number. So definitely any number which is divisible by 1 and the number itself, right? 1 and the number itself is known to be a prime number. So can you say that 15 and 24, they are not prime numbers? Why so? Because what is the condition to be a prime number? That it should have exactly 2 factors. Here you can see 4 factors, here you can see 8 factors. So they are not prime numbers. So let us take a case of prime numbers. Let us take 2. So if I write factors of 2, you can see it is divisible by either 1 or 2. Now let us take a bigger number. Let us take 17. 1 and 17. These are the only 2 factors. We are just writing the factors by using our tables. I hope all of you are comfortable in tables. So 17, its factors are 1 and 17 itself. So if I talk about 23, only factors are 1 and 23. So 2, 17, 23, they are not to be prime numbers. They are prime numbers. Now, let us read more about prime numbers. Yeah, it is always advisable that you should remember all the prime numbers from 1 to 100. So first of all, the very first point that you should remember, how many prime numbers are from 1 to 100, guys? They are 25. There are 25 prime numbers from 1 to 100. So let us revise them. First of all, this is the list of all the prime number 2, 3, 5, 7. They are the prime numbers from 1 to 10. Now next range, 11, 13, 17, 19. So they are the prime numbers from 11 to 20. Now the next line, if I take 20 to 30 range, 20 to 30, there are only 2 primes. Now, if I take this 31 to 40, there are only two primes. Now, 41 to 50, there are three primes. Similarly, if I take next 10 numbers, I mean 51 to 60, there are only two primes. Going further, 61 to 70, two primes. Now going further, 70 to 80. How many prime numbers, guys? Don't miss this 71. So there are three. Now coming to next range, it is 81 to 90, two numbers, and 97 is the only prime number which is more than 90 but less than 100. I mean, in the last line, if I take counting from 1 to 100, in the last 10 numbers, I mean 91 to 100, this is the only prime, 97. Correct? So you should always remember. Now you can see they are 4. They are 4. They are 2, 2, 3, 2, 2. Then we have 3. Then we have 2. Then we have 1. If you add up all these numbers, you will get what? You will get 25 numbers. So from 1 to 100, how many primes are there? There are 25 prime numbers, guys. I'm telling you again and again so that you can imbibe this number, 25 prime numbers. And to be very precise, you can remember this as well, that from 1 to 50, how many prime numbers are there? They are 15 prime numbers. And further, 51 to 100. How many prime numbers, guys? There are 10 primes. As you can see, 15 plus 10 will give you 25. Now let us talk about some properties of prime numbers, because many questions are made on this important topic. That's why we should discuss each and everything related to prime numbers. First of all, 2 is the only even prime. Very, very important observation. 2 is the only even prime. Second, except 2. I can say except 2. I'm going back to my list. If I go to this list, you can see this 3, 5, 7, 11. All of them are odd numbers. So 2 is the only even prime. Second, whenever a prime is divided by 6, remainder is either 1 or 5. Right? Let us see. If I take 31, I told you 31 is a prime number. So 31, when we divide it by 6, you can see what should be the remainder. It should be it should be 1. Now let us take 37. When we divide it by 6, we'll get what remainder? We'll get 1 as the remainder. I hope all of you are getting me. So whenever you divide any prime with 6, particularly this number with 6, we'll get either 1 or 5. Can you think of a prime number which when divided by 6 is giving you a remainder of 5? Just pause the video. Try to remember all the primes. Now let us take a number which when divided by 6 giving a remainder of 5. 5 only. When we divide it by 6, we are getting a remainder of 5. Right? We could think of more numbers. Let us take 11. 11 when divided by 6, what will be the quotient? It will be 1. So what will be the remainder here? It will be 5 only. So this is very important property of a prime number. So guys, that's it for today. We'll meet you in the next session. That will be the next session, continuation of prime numbers only. We'll be discussing composite numbers, what do we mean by co-prime numbers, and so on. Thank you so much. Happy learning.